Now we are going to learn about confidence interval estimation. So first case is when sigma is known to us. So let us write the code for that. So let me just add a comment that sigma is known. In that case, what will be the confidence interval for the population mean? So first of all, we are going to import numpy as np, and from scipy.stats we are going to import norm, because we are going to work with the normal distribution. So as you know that numpy, we have been using numpy for scientific computing and or for all your numerical operations, and the norm module we are importing from your scipy library in order to work with the normal distribution. Next, we would set the random seed to 0. So np.randomSeed 0. It specifies that the same random numbers would be generated each time the code is run. It won't change at each run. And let us consider the true population parameters as, so let us take the true mu as 5 and true sigma. So we have taken the same parameters earlier also for point estimation. So we are sticking to that same thing. Next, we are going to generate a random sample. Generate a random sample from a normal distribution. So in this case, let us assume that the sample size of 100 would be taken, and your variable data sample would store a sample that is generated from the normal distribution. So we would write np.random.normal, and in bracket we would write true underscore mu, true underscore sigma, and size would be the sample size. So we have used this earlier also, so let me just explain it once again. So here this is a function that generates random numbers from your normal distribution. This true mu and true sigma basically represents the true population mean, and this is the true population standard deviation of the normal distribution from which we want to take a sample, and this is the sample size, that is the number of random numbers we want to generate for your sample. So basically by performing this, it will generate a sample of size 100, or you could say that it will generate 100 random numbers from a normal distribution with mean 5 and variance 4, and it would be stored in your variable data underscore sample. Now we would calculate the sample mean, because in population, if you recall, your confidence intervals are built around your point estimator. So for mu, when sigma is known, in that case x bar is your point estimator. So in this case also, first we would calculate the sample mean, which comes out using the np.mean function. So data underscore sample. Okay, now we need to set the confidence level. So let the confidence level be 0.95. As you know, this is the most common one, and we have discussed the reason for this being the most common one. After confidence level, we will calculate the critical z values. So let me write the comment, calculate the critical z values. So for this, let alpha be 1 minus of confidence level, and your z critical would be nor dot ppf 1 minus alpha by 2. So basically what we are doing over here is, here we are calculating the critical values for a two-tail test. So this alpha basically represents the significance level, which is the probability of making type 1 error, that is rejecting a true null hypothesis, and z critical is calculated using the percent point function, that is norm.ppf. This is the percent point function from the normal distribution. Okay, so it corresponds to the z value at which 1 minus alpha by 2% of the data falls on each tail of the distribution. So 1 minus alpha by 2 on each side. And then after this, we can calculate your margin of error. Let me just write, calculate the margin of error. So margin of error, as you remember, so I can just write margin MOE, I can write. Okay, so margin of error. So this is z critical into true sigma, so which is sigma divided by square root of n. So we need to write np dot square root of the sample size. Sample size we have already defined earlier. Okay, so here we have calculated the margin of error. Margin of error basically is a measure of the uncertainty in the sample mean. So here we are calculating it by multiplying the critical z value by the standard error of the sample mean. So in this case, the standard error is given by true sigma divided by sigma by root n basically. Now once this is calculated, we can write the confidence interval. Calculate confidence interval for mu. So this one would be, so just write Ci would be, so sample mean minus MOE, minus of margin, minus you subtract the margin of error, and on the other side you would add the margin of error. Now you can finally print. So let us first print what was your true population parameter. Or you can write true population mean. So in this case, it would be true mu. Next would be your sample mean, because we should see what is the point estimator also in this case, and also because your confidence, it would be easier to see how your confidence intervals are built around your sample means. And finally we would print your confidence interval Ci for mu. So here this value would be Ci. So true population mean was 5, sample mean came out as 5.11, and the confidence interval that we have obtained varies from 4.727 to 5.116. So you can see that your confidence interval for mu is centered around your sample mean, and population mean is in fact within that only. So you have come up with an interval estimate for your population mean, which is a good estimator in this case, as it can be seen. So what we have done primarily over here is that we have imported the necessary libraries, and then we have defined and set the true population parameters and generated a random sample from normal distribution with the specified mean and variance. We have calculated the sample mean, and then we have specified the confidence level. After that, we have calculated the z values, margin of error, and then finally we have been able to calculate the confidence interval. Now the next thing could be, let us see how this thing confidence interval varies by changing the parameters. Okay, So let me just write varying parameters so we import numpy as np from scipy dot stats import nor, we need this, and we also need from matplotlib import matplotlib dot pyplot as plt. So this one we have used earlier, these two we have used earlier also. This matplotlib, this is used for your visualizing different plots and charts. Okay, so for that purpose we are writing it over here. Now the true population parameters, we can take them as same as we have already defined them over here. So mean 5 and variance will be 4. Now let us see what are the varying sample sizes. So let us define, so in the previous one we fixed the sample size as 100, and in this case let us use this function np.arrange 10, 201 and 10. So this shows basically that this is a numpy array that represents a range of sample sizes. So now it will start from 10 and it will increase by 10 and go up till 200, because 201, and as you can recall, it takes, Python takes one value less than the final argument that we give, so it will go up till 200, and that is why we have written 201. Okay, so it means that you are interested in studying the confidence, how confidence intervals change as the sample size varies. So we can write confidence levels also. So we want to see at different confidence levels, so 0.90, 0.95 and 0.99. Now we will create a list to store the length of confidence interval for different sample sizes and confidence levels. So let me just write interval underscore lengths as empty over here. So this line initializes an empty list called interval lengths. So it is meant to store the length of confidence interval for different combinations of sample sizes and confidence intervals. So now we will see what happens next. So we are going to initiate a for loop for confidence level in confidence underscore levels. So we will create this empty list, length is empty. It will store the length of the confidence interval for each sample size at the current confidence level. So first of all, it will initiate a for loop over here. So it will pick a particular confidence level, and then here in this place it would store the length of the current confidence level that has been picked. Next we write for sample in sample sizes, data underscore sample. So from here we are going to generate random variables from random numbers from your normal distribution with the mean true mu, mean 5, variance would be your true sigma, or you can say standard deviation in this case, and your sample size is the sample size. Then it would calculate the sample mean using the numpy.mean function. One minus alpha will be 1 minus of the confidence level, and z critical would be norm, we have used earlier also, ppf, norm dot ppf. So this one would be 1 minus alpha by 2. So yeah, this is your percent point function of the normal distribution. So basically we have iterated a for loop over here over the sample sizes, different samples in this sample sizes, and for each of them, for each sample size, it generates a random sample, that is this, and it calculates the sample mean. It will calculate the value of alpha and z critical value. After this, it would calculate the margin of error also. So let me just write MOE here. Margin of error would be z critical into sigma by root n. So true sigma divided by NP dot SQRT sample size. Next we would calculate the confidence CI length, CI underscore length. So it would be twice of the margin of error, MOE. So length of the confidence interval would be sum up, twice of the margin of error. We have discussed these topics in class also, and now we are going to finally append it, lengths dot append CI underscore length. So here basically it is your confidence interval length is determined by doubling the margin of error as it is symmetric around the sample mean, and then this length for the current sample sizes would be appended to the lengths list, and this length would be finally appended to this interval length that we have calculated over here. So it would be shifted a bit this side. So interval lengths dot append lengths. So the length list for this particular confidence level that you have obtained over here, it would be appended to the final list. Sorry, so here I have defined lengths, let me write lengths. So here it would be interval lengths. So probably I can just write here also. So finally we are going to create a plot to visualize this. So first of all we would write plot dot figure, fig size, let us take as 10,6. okay, so this would basically create a new figure for the plot, and size 10 inches in width and 6 inches in height. Then for I in confidence levels, for I confidence level in enumerate confidence so for I confidence level in your confidence levels that we have already taken over here, for this for loop over here, it will iterate over different confidence levels and it will plot. So let me just write the command first, plt.plot. So we need an x-axis for this. So in x-axis we will write the sample sizes, and for the y-axis we need interval lengths, interval underscore lengths I for the current confidence level, and it would be labeled as confidence level. what confidence level is there. So let us see what it is. So first this will be evaluated and then finally it would be printed. X-axis, this is Y, and this would be the label for your plot. After this loop is completed, then finally it would print the X label. So let us write X label as sample sizes and Y label can be your CI length, confidence interval length, plt.legend, let us have that empty. You can also name this title. So this is confidence interval length versus sample size. If you want the grid, we can write that also. So we have used these commands earlier also, so I am not going in detail because here finally we are going to display. Okay, so here I have written the entire code in one step over here, one input line. So after this, if I run it, so what I'm getting is in this way. So you can see that for different sample sizes, as the sample size is varying, your confidence interval length also you can say it is varying. For confidence level 0.99, that is, it is green in color, so it starts from 3 over here and it decreases up till 1 when you are increasing the sample size. Likewise for blue, you can see for 0.95 it is in between these two, starts from somewhere around 2.5 till and it decreases till somewhere around 0.75 or 0.6 here. So you see that how by varying the sample sizes, different confidence intervals or the length of the confidence interval also can vary.